Welcome to my civil engineering YouTube channel. Please subscribe to this channel and hit the bell icon to get notified when I post my new videos. Today I'll be discussing how to analyze the unknown force along with its inclination of a coplanar concurrent force system. So here in the sketch you can just observe uh, four coplanar forces of 200, 500, again 200 and P, which is unknown, is given in the question. So here, one of the forces is unknown. So here, the unknown force is considered to be as the magnitude of P, which is having its inclination of theta. So here, yeah, they have also provided the value of the resultant of magnitude equal to 500 Newton. So they have given the the value of the resultant as 500 Newton, which is exactly on the x-axis, which is acting exactly on the x-axis. Now they have asked to determine what is the value of this unknown force, that is in terms of magnitude, and what is its inclination with reference to the horizontal axis, that is x-axis. So before proceeding with this problem, we just go on with some cases. So case 1. Suppose I need to determine the unknown force. I need to determine the unknown force. In this case, if R is given in x-axis itself, suppose I need to determine the unknown force. Suppose if the unknown force is of magnitude equal to P at an angle of theta. In this case, I need to determine the value of P and theta, and also if the resultant is given exactly on the acting on the x-axis, then the sigma h is equal to R. It should be equated to R, and sigma v is equal to 0. In order to determine the magnitude of magnitude of the unknown force as well as its inclination, if the resultant value is given which is exactly acting on the x-axis, if at all if the resultant is acting exactly on the x-axis, then in such case the sigma h and sigma v will be equal to, sigma h is equal to the resultant and sigma v is equated to 0. So next, coming on to next case, that is case 2. So suppose in this case, if resultant is in vertical axis, so here in case 1, R is in x-axis, So here if R is in y-axis, so suppose R is in y-axis, R. So in such case, sigma h is equated to 0 and sigma v is equated to resultant R. So I just repeated. So in case 2, so if the resultant is lying exactly on the y-axis, then in that case, in order to determine the value of the unknown force P as well as its inclination theta, so sigma h is equated to 0 and sigma v is equated to R. So next is case 3. So here in this case, suppose if R is at some inclination, so if R is at some inclination with reference to, suppose if I just call it as alpha. So if R is at some inclination with reference to the x-axis with an angle of alpha. So in this case, R is inclined. So in this case, sigma h is equal to, so before taking sigma h and sigma v values, so this is the resolution R cos alpha and this is R sin alpha. So therefore, sigma h will be equated to r cos alpha, and sigma v is equated to r sin alpha. So whenever if r is given in a problem, so whenever, so suppose this is the inclined force P, so at an angle of theta, in order to find out P, so if suppose the value of r is given which is inclined at certain angle of alpha in a question, if it is given, so then in order to determine the value of P and theta, so then you are supposed to equate sigma h as r cos alpha and sigma v as r sin alpha. So the last condition is that case 4. Case 4. So in this case, suppose if alpha is with reference to vertical axis. So in that case, so suppose, and this is P. So one second. So if this is x-axis, x-axis. So if this is P and theta, suppose. So in this case, the resolution will be, this will be r sin alpha and this will be r cos alpha. So this will be reversed. So sigma h will be equal to r sin alpha and sigma v is equal to r cos alpha. So these are some of the cases wherein to determine the value of the unknown force, whenever if the resultant is given irrespective of the axis. So if at all if it is given as x-axis, sigma h is equal to r and sigma v is equal to theta 0, and if it is exactly on the y-axis, sigma h is equal to 0, sigma v is equal to r. If it is inclined with reference to horizontal axis, sigma h is equal to r cos alpha and sigma v is equal to r sin alpha. So if at all if it is inclined with reference to vertical axis, then sigma h is equal to r sin alpha and sigma v is equal to r cos alpha. So coming on to this numerical, so we have the first case, means the r is exactly on the x-axis, and therefore sigma h should be equated to r and sigma v is equal to 0. So coming on to solution of this problem. So as I said in the earlier class that, we have only two equilibrium condition as far as coplanar concurrent force is concerned. So it is sigma h and sigma v. So first and foremost thing is that finding sigma h and sigma v. So first of all, sigma h should be equated to r and sigma v has to be equated to 0. So before finding this is equal to 30 degree. So before finding this, so we need to resolve the forces. So first I take um, 200 Newton. So this is at the angle of 45 degree. So 200 Newton, the resolution will be 200 cos 45 and this will be 200 sin 45. So 200 cos 45 and 200 sin 45. Next, coming on to this force, that is 500 Newton. So if I just, it is in third quadrant, So in the same way, if I draw that, so this is the resolution force 500 Newton. It is acting at an angle of 30 degree. So the resolution will be equal to 500 cos 30 and this is equal to 500 sin 30. So as per my sign convention, in the earlier class I said that as per my sign convention, for the horizontal force sigma h, so right side force is taken as positive and left side force is taken as negative, and sigma v upward force is taken as positive and downward force is taken as negative. So with this sign convention, if I want to proceed, so I just find out what is the value of sigma h. So sigma h. So starting from the force 200. So sigma h should be equal to r first of all. So here sigma h is 200. So this is cos 45. So 200 cos 45, it is in the right side direction. So as per my sign convention, it is positive. So it is plus. So next is here, before going to the resolution, we need to, I mean, before solving this, we need to determine the resolved force. So this is 30, so this is P. So this will be P cos theta and this will be P sin theta. So next is coming on to the unknown force, that is P. So here the horizontal resolution is P cos theta. So therefore it is P cos theta. So since it is going in the left side direction, so as per my sign convention, it is negative. Hence, I have reflected the same sign convention here. So next is 500 Newton. So 500 Newton, the resolution is in the horizontal direction is 500 cos 30. So 500 cos 30, it is, since it is going in the left side direction, so 500 cos 30 is equal to, I mean, it is in the negative direction. So we need to equate this to the resultant R. So since it is in the right side direction itself, so it is positive, so it is 500 itself, 500. So next coming on to sigma V. So sigma V, so before proceeding that sigma V, if I just simplify this, I'll get P cos theta is equal to, P cos theta is equal to minus 971.59 Newton. So minus 791.59 Newton minus 791.59 Newton, or else you can also show this in the sign, that is in the left side direction. Since it is negative, you can just show in the direction, as we know that left side indicates the negative convention. So 791.59 in the left side direction. So next is sigma V, it should be equated to 0 as in case 1. So here sigma V, starting from 200 Newton. So 200 sine 45, as per my sign convention, upward force is taken as positive. So it is plus 200 sine 45, plus 200 sine 45. So coming on to this unknown force resolution P. So this is P sine theta. So P sine theta, it is a positive variation which is going in the upward direction. Hence it is P sine theta. So next it is 500 Newton force. So its resolution is 500 sine 30 in the downward direction. So as per my sign convention, it is negative. So therefore it is minus 500 sine 30 equal to 0. So after simplifying this, I'll get what is the value of P sine theta. P sine theta 308.579 Newton. So since it is a positive value, I can also show in the direction. I can just reflect in the direction. Since it is in the upward direction, the positive value, I have shown it as the upward arrow here. So now I got two values of P. So one is P sine theta and another one is P cos theta. So if I just divide this, I just call this as equation 1 and I just call this as equation 2. So if I just divide 2 by 1, so if I just divide 2 by 1, I'll get P sine theta, P sine theta divided by P cos theta is equal to 308.579 divided by 791.59. This is a negative value. So if I just simplify that, I'll get it as theta as minus 21.29. So minus 21.29 degrees. So theta is equal to minus 21.29 degrees. So minus 21.29 degrees. So since it is going in the anti-clockwise direction, hence it is a negative variation. So since it is going in this direction, so here this is going in this direction. So so it is going in this direction, the anti-clockwise direction. Hence it is taken as negative. So next is to find out what is the value of P. So as I know the value of theta here as 21.29. So if I just substitute that value of theta either in P sine theta or P cos theta, and if I just equate to that value I have got, after simplification, I'll get the value as P is equal to 849.61 Newton. So this is the positive value. So it is in the and this is a positive value. So further simplification of theta with reference to either equation 1 or equation 2, I'll get the value of P as 849.61 Newton. So here with this we have got what is the unknown value of the force P as well as its inclination theta. So since it is in negative direction, it can be treated as anti-clockwise variation. Thank you for watching. Please like, share and subscribe the video. Thank you.